Alrighty, so we're going to be talking about two things, standard deviation and the normal curve. To start, when we're talking about standard deviation, we need to do a little review, and that is of the word mean. So the mean of a set of data is the statistical average of a set of data, right? It's that thing where we add them all up and we divide them by the total number. So if you need that reminder of what it is, we add up all of our terms, we divide by the total number, and that gives us our statistical average. Now the standard deviation is a statistical measure, so it's another thing that is using those numbers, that data set, and also some mathematics that we apply to it that shows how much the data values vary from the mean of a set of data. Okay, so it says how far apart are those values from the mean, from the center. So not from smallest to biggest, but from the center. AKA, they tell us how spread out the data is. Okay, it says, is our data really, really tight and really combined and really close, or is it really spread out? The higher the standard deviation value, so the higher the number that we get when we find the standard deviation, the more spread out data is. And we'll talk a little bit in the coming weeks about whether it's beneficial to have spread out data or not spread out data. But the higher the standard deviation value, the more spread out the data is. Okay? So what is a standard deviation? Well, when we find the standard deviation, we have this equation that says the standard deviation is equal to the square root of the sum, that little sign says sum, and I'll make a note of that in a second, of the x terms, or the terms of our information, minus the mean squared over the number of terms we have minus 1. Whew, that's a lot of things. So S is our standard deviation. This sign is called sigma, and it means add up the terms. So we're going to add up xi, which is a term in the list or a piece of data. X with the line over it is the mean, and n is the number of terms we have. Now would be a good time, if you are listening to the video, now would be a time to write down the word key and turn it into Miss Holmes. Thank you for listening to the video. So all of those pieces, all of what it's saying is it's saying we're going to take each number and we're going to see how far away from the mean it is. Okay, how far away from the center it is. We're going to square that difference. We're going to add up all the terms for every single time we do that with every single number. We're going to divide it by the number minus 1, and then we're going to square root that, and that's going to get us our standard deviation. So it's really, really messy and confusing. We can do it in our calculator. Okay. Now the calculators that we have in the classroom do not have the feature for this. So instead we are going to use Desmos calculator. So what I would like for you to do is, that's not what I want, is to go and I want you to search Desmos calculator. Okay, and you're going to click on the scientific calculator. And once you get to the scientific calculator, you're going to click on functions, F-U-N-C. And then you're going to click on where it says, standard deviation. Why is this not letting me? This is going to be a problem. Standard deviation, STDEV. And then you're going to type in whatever numbers are in your list. So maybe you have 60, 70, 80, 90, 100. And then it's going to give you your standard deviation value. So you don't have to do the adding up. So you're going to go in your calculator. Desmo Scientific. Function. STDEV. And then you're going to type in the numbers, and it will give you your standard deviation. So you do not need to type in or solve the whole thing. You just need to use your calculator to do it. Okay? So what does all this really mean? So I have some scores of a test that Regina, Sarah, and Trisha have taken. They've taken 6 tests, and these are their scores. To start, we're going to find their means. So Regina's scores are 70, 70, 70, 70, 70, 70, and there are 6 total scores. So what I'm going to do is I'm going to go to my calculator, and I'm going to find the mean, which is where I add them all up and divide by however many I have. So I have 70 plus 70 plus 70 plus 70 plus 70 plus 70. Okay. Oops. That's 420. And then I'm going to take 420 and divide it by the 6 values that I have, which gives me 70. So my mean for this is 70. So when I go to Regina's mean, it is 70. I'm going to do the same thing for Sarah's scores. Okay, so I'm going to go to my calculator, I'm going to add them all up and find the mean. So I have 75 plus, 75 plus 65 plus 73 plus 67 plus 71 plus, what's my last value? 69. So I also get 420. I'm going to take 420 and I'm going to divide it by the 6 total, so I get 70. So Sarah's mean is also 70. And in my calculator, I'm going to take Trisha's scores, I'm going to add them all up, I'm going to divide it by 6, and I am going to actually get 70 as well. So the mean for all of these data values is the same. It happens to be, it happens to be 70 for all of them. So that means that the average is 70 for all of them. Even though the data is different, the values are the same. Now it's going to ask this question, which student will have the highest standard deviation and why? Well, I know that standard deviation means how spread out my data is. So I want to look for what has the values that are the furthest away from 70. And I find that Trisha has 90 and it has 50, which are both 20 away from 70. So Trisha, 90 and 50 are both 20 away from the mean being the most spread out. So I'm looking at where is my data? I have these numbers that are furthest away from my average, which means that they are going to give the most spread to my data, and therefore it has the highest standard deviation. The lowest standard deviation is going to be Regina, because all the values are the same as the standard deviation. All value, or as the mean, sorry, are the same as the mean. which means that our data is going to be really, really close together. It's all the same numbers, so it's all super close together, which is a good thing, okay? I'm going to take a minute then to go into my calculator and type in my my values into the standard deviation. So in my calculator, I'm going to click on function, standard deviation. Oops, we're going to reset that. Standard deviation, and I'm going to type in 76 times for Regina's score. And I get a standard deviation of 0, which makes sense. If we're talking about how far away from the mean it is, and it is the same value, then it's going to be the same value, or it's going to be 0. There's no difference. There's no distance. Okay? I'm going to do the same thing for Sarah's scores. I'm going to type in standard deviation, that button there, 75, 65, 73, 67, 71, 69, and I get a standard deviation of 3.74. So that's what I'm going to write for my standard deviation, 3.74. Okay. And lastly, we're going to find the standard deviation for Trisha. So I click my STDEV button, and I have 90, 50, 82, 58, 79, 61. And I get that my data is 15.8 standard deviation, or standard deviation of 15.8. So we were right in our predictions that Trisha is going to have the highest standard deviation because the data is furthest away from the mean. Notice that the standard deviation is not just subtracting, okay? It's not just a subtraction, but that it helps us to find how, it's a measure of how spread out our data is, okay? And I believe that is it for this video. So there is a second video about the normal curve. This covered standard deviation and how to find it.